Hello and welcome to Hackett's Cove, Nova Scotia and the Nautel RF Toolkit Radio Coverage Tool webinar. And we're very glad you're here. I'm Chuck Kelly and I have a special guest today. Mr. Roger Coudet is the developer of the software called Radio Mobile, and he's in Montreal. And Roger, can you hear me?
Yes, Chuck, I'm there.
Wonderful. Welcome to our webinar, and thank you so much for being a part of this presentation. So we have a pretty quick plan for this webinar today. We're going to talk about what the Nautel RF Toolkit is, how does propagation analysis work, and what are the limitations of it, what can the Nautel radio coverage tool do for us, and where can we find the radio coverage tool. And then we're going to spend most of the webinar playing with it. We're just going to get on and create some sites and create some coverage models and see what happens. We do have the opportunity to take your questions. So if you look at the right-hand side of your screen, you have the opportunity to type in questions. And if you'll type questions and or comments, we will do our best to answer those prior to the end of the webinar, just before we finish the webinar. And if you can't get it in by then, we will do our best to email responses back to you after the webinar is closed. So the first question is, what is the Nautel RF Toolkit? Well, as the title says, it's a set of tools designed to help both technical and non-technical people easily understand complex systems. It allows users to analyze possible transmitter locations, tower heights, antenna gains, and transmitter power levels, and predict coverage for those. And while it's based on solid engineering principles, these tools cannot replace the services of a qualified consultant. Let me reiterate that one more time. This is a tool to help you get a basic understanding of an average of how things might work, what kind of coverage you might have based on a particular transmitter location, tower height, antenna gain, and transmitter power. It is no replacement for a qualified consultant, and I certainly would never be in a position to file for a license or buy broadcast equipment or anything like that simply on the basis of this tool. This is just a gross approximation, and it's not guaranteed in any fashion. So how does radio coverage prediction work? It's based on Longley Rice, the ITS algorithm. And it covers, what, 20 megahertz to 20 gigahertz, something like that, right, Roger?
Yes, you can use on an extended frequency range, but I mean, it will not take into account like a ionospheric propagation.
Exactly.
Or
it's not going to know what's going on with the E layer.
Neither in high frequencies, you will have rain and things like that.
Sure.
That are based on
beyond the capability of the model. That's right. So this is a website you can go to in which will take you to a document that describes the basics of the ITS, commonly known as the Longley Rice algorithm. And it gets very useful for understanding what this algorithm is doing. It utilizes a digitized terrain database, which is available from NASA, called the SRTM data, Shuttle Radar Terrain Mapping. So this was really the space shuttle flying over, firing radar off the ground as it flew over, and then taking the results and putting it into a database. Is that right, Roger?
Yes, this is most of the data come from that shuttle flight, but on top of that, we have now a lot of other source of data that, especially for the northern and southern extreme, you have a source that are based on maps or radar sat for the Antarctica and things like that. Yeah.
So what kind of accuracy of data are we looking at in North America and then perhaps in the rest of the world? Okay,
so most of the 48 contiguous states of the United States are at 1/3 of an arc, which correspond approximately to 10 meters.
Okay.
In Canada, we have a resolution typically of 30 meters, which is 1/2 of an arc.
Okay.
And in Europe and the rest of the world, it's mostly 100 meters.
Okay.
There are some specific location that provides better resolution, and in that case they are there. Like I think Switzerland is one of
Okay.
in our database. But every data that was freely available, the best we had in the world is there.
Okay. Now another question: how much space does this database take up that you've got running on your servers?
Yeah, we're talking close to a terabyte, so it's hundreds of megabytes.
Right. Okay. That's wonderful. I'm glad I'm not hosting it on my computer. So,
yeah,
go ahead.
And just one mention that it's not only based on terrain elevation, we also have clutter information, like is it a city, is it a forest, and it is added to the Longley rice model. So we do not have only Longley rice. We also have supplemental calculation based on the clutter.
That's the ground cover.
Yeah.
And that explains it. So the propagation of the signal going through a forest might be different than a city going through, passing over the ocean, and it's the Longley rice model is taking that into account and doing its calculations.
Yeah, it's added to the it's not originally in the Longley rice.
Right. Okay. So there are two basic parts of this tool. There's coverage predictions over an area, and there's point-to-point analysis. So this is coverage prediction over an area, and this is a point-to-point analysis. And this is useful, for instance, this one would be useful for figuring out how far your FM station is going to go, and this one is going to be useful for things like STLs or RPUs. And we'll talk about that too. And it's based on software developed by you, Roger Coudet, in Montreal, and he actually has some free software which is available called Radio Mobile, which is wonderful software. I've been using it for many years. It's really excellent. And Roger, I don't know how the industry and the amateur radio community can thank you enough for your hard and tireless efforts in this software. Okay, so let's talk about how we will find it. It's free on the Nautel website, and you can go to www.nautel.com/RF Toolkit, and with the tool you can see an estimated coverage of an FM station plotted against map and save the generated map and plot an STL path and see if it's likely to be reliable. So let's see it in action. And this is the most fun part of this whole presentation. So let's scoot over to a web browser. And now hopefully everybody can see this Nautel website here. And if you scroll down, you can go to the RF Toolkit here. And you can get a free account over here under Register. You can change and get your forgotten password. As I said, it's completely free. But I already have a password and it knows it, so I'm going to just go ahead and log in. And now I'm logged in, and now I can click on the radio coverage tool. And this is the main menu for the radio coverage tool. So I can look at, and let's start with what you would do if you were starting in a site. So the first thing we would want to do is create a new transmitter site. Now if you haven't logged in before, it's likely to show you in the middle of the Atlantic Ocean off the coast of Nigeria, because that's where 0 degrees latitude and 0 degrees longitude intersect. But in my case, I've already got a site located right here where Nautel is located, and I've created a location, and I can move this any place I want. I can go take and create a site over here in Yarmouth, Nova Scotia, and I can zoom in on that site, and like that, and pull this down a little bit, and I can center at the cursor, and then I can zoom right into it. And I can even switch back and forth to a satellite view to make sure I know exactly where this transmitter site is going to be located. It's going to be right there. And now I can submit this. And now you see it's going to be called new transmitter site number 3. And if I go over here, if I actually got it close, but I know what my latitude and longitude is, I can actually locate that. I can enter that information up here in degrees. Remember that in North America we are west of Greenwich, therefore you see it's a minus number here for the longitude. And we can name this site. So we're going to name this Yarmouth. And we will do this, capital, comma, NS. And we will add transmitter sites. Now I have, I believe, 3 transmitter sites here. And the first thing I want to do is I'm going to do a coverage plot. So I'm going to use my new Yarmouth site and use 100 megahertz as the center frequency. And I'm going to say my tower is going to be 20 feet, or the center of the antenna will be 20 feet AGL, or above ground level. And I'm going to choose a 1 kilowatt transmitter with a 4-bay antenna. And I'm going to assume that I'm looking at a car receiver. And I'm going to assume 150 kilometers maximum range, and the opacity, the color of the signal. It's not going to obscure the map at 40% opacity. Okay, so I'm going to hit submit. Now, Roger, what's the program doing at this point?
Okay, the first half of the progress bar is related to the extraction of the elevation data. It's all happening on the server. And you see the resulting resolution is 300 meters. So we selected a range and an image size that end up with a 1000 by 1000 pixel. Since we have a 150 kilometer radius, it gives 300 meter per pixel.
Okay.
And now we see that it's packaging the file after computation is complete.
And now we have a drawing, a coverage map, and you can see here that I can zoom in it. I can do all sorts of good things. Now, if I want, I can add this to my coverage plots. And I can do it like this. So now if I go to my coverage plots, I can pull up that one, and I can view it. And if I move it over to the right-hand side and zoom in just a little bit, then what I can do, and you notice here that the yellow area is good out to about 34 dBUV, which is just about as using a car receiver with an antenna 1 meter above ground, that's just about as weak as you can still hear the station, 34 dBUV. And 44 dBUV is the green, so that's a pretty reasonable signal. So now what I can do is I can go and click this. Well, the key question is, let's first look at this. Roger, you've included the capability to see some files, and it's downloaded those files. Now I'm going to open up those files. Can you explain what are, let's say I need to show everybody these files. I'm going to show it as a screen here. So can you show everybody or explain to everybody what these files are?
Okay. So the first file is the PNG file is it's the coverage itself.
Okay, I'm going to show that. That's it right there.
No map behind.
Yeah. Okay.
And that can be useful to be merged. As an example, if you press the KML,
right.
Don't forget.
I'm not going to do that right now. Yes. Okay.
If you unzip that and you can open it with Google Earth, the KML file will show your coverage in Google Earth too, and you can also, as a double check your how the elevation and the clutter or the ground cover look like.
Oh, I see. This is the ground cover map for Nova Scotia.
Kind of a confidence test.
Sure.
That everything was okay.
Okay. And then the elevation data. That's the elevation data. Yep. Okay.
And you see that there are other files that Radio Mobile software can understand. So it could be georeferenced.
Okay. All right. So now let's say that people don't want to necessarily use all that stuff. They want to actually see what they can see on the screen here. So there's a little trick you can do. And by the way, if I hit this description, a lot of the technical data related to this particular location will pop up. So I can take, and if I hit the print screen button on my PC, I've just done that, and if I bring up my graphics program, I happen to use a freebie software called orphanview, and I can paste that in, and then I can very easily come over here and just isolate it like that, and then crop it, and I can save that file, and I've got the coverage map over here. I've got the technical data related to that, and I have a legend up here of not only the signal strength contours that correspond with the colors, but also the number of square kilometers that is within that coverage area. So just a little bit over 3,500 square kilometers are within the 33.7 dBUV contour, and the program is predicting the 43.7 dBU contour to be about 1,703 square kilometers. Is that correct, Roger?
Yeah.
Okay. So that explains how to do that kind of presentation. Now there's another thing that we can do that's pretty cool. Let's return to the main menu. I now have several coverage plots in here, and I can take and combine them on one map, and now I can see, whoops, it didn't show the one down in Yarmouth, so I'll have to figure out why. But
maybe you just press the button.
Yeah, don't know what happened. In any case, let's just move on. So the key here is that I can turn on and off multiple coverage areas. I can see which the transmitter site in Aspetargan is contributing that to the coverage, and the transmitter site at the Nautel factory is contributing that to the coverage. Very useful way of seeing how you might be able to construct a network for instance. Okay, now let's come down here and return to that, return to the main menu, and I just want to show everybody how to do an STL link. So let's take and create an STL link that's 10 meters from the Nautel site and go to the Aspetargan site. It's also 10 meters above ground level. And let's say the frequency is going to be 945 megahertz. The transmitter power is 10 watts. The loss is going to be a bit higher, so let's say 2 dB. Transmitter gain, this is also 5.4 and 2 dB. And let's use all of that data just like that and see what happens. Okay, so the program at this point has created a profile where we are seeing those two sites which are shown on the map here. So you can see here, this is where the Nautel factory is, and that's the Aspetargan site. And now it has created that in profile with an exaggerated height dimension. Is that right, Roger?
Yes. The scale automatically adjusts.
So what's happening here is this is the Nautel site that is doing the transmission, and the beam going to the receiver site is left to right, the green line.
So the green line shows that the signal is good. If it would have been red or yellow.
Sure.
Yeah.
Especially if this hill over here would have been higher, it would have interrupted the beam.
Yeah.
And so now we have also, if we're driving this path, or in this case over here, boating it's the path, you'll see you have good coverage all of that way except for down here in this valley because it's being shielded by this hill. Because the green line shows us that we have good coverage and the red is saying not so good. And we also have these green and light blue areas and yellow areas. What are those, Roger?
You mean on top of the ground?
The dark green and the yellow.
Okay. That would be forest, small cities in this case.
Mm-hmm.
Blue. And I don't see that. Okay, maybe some grass in the yellow, yeah.
Okay, all right. So then we have a whole bunch of technical information here below which shows the latitude and longitude of both the transmit and the receive site, the calculated ground elevation that came out of the SRTM data, the antenna heights, the azimuths, the tilt, and then the radius performance guesstimates of the 10 watts is equivalent to 40 dBm. Mm-hmm. You got the free space loss, the obstruction loss, showing how much you're losing due to the forest. And then we have the distance and the precision and the frequency and anything else of interest here, Roger? Tremendous amount of information.
This is typically what we call the radio link budget.
Mm-hmm.
So it's based on the the global path, including the system and the environmental stuff.
Okay.
So you can separate them in two boxes like that. It's better. It's easier to figure out what's happening if you have a problem. Now everything is green, so it's okay. But
yep, that's a pretty short path, as a matter of fact.
Yeah.
Yeah. So let's go back, and I want to see if we've got any questions. We've just about reached the end of our presentation. I want to see if we have got any questions here. All right. Let's see. It looks like we got several. It says one of them is that he's having trouble doing it in an Internet Explorer. Is there any? I was doing it in Chrome. Are there any browsers that have difficulty that you're aware of, Roger?
Not supposed to. Maybe in the multiple coverage, some of the icon won't show up in Internet Explorer, but this is very, I mean, a very little thing.
Okay. The next question is what coordinate datum is used?
It's when we refer to lat long, okay, horizontal positioning. This is spherical coordinates for the Earth, okay.
Right.
The vertical, the elevation is based on the accuracy of the SRTM stuff and the mapping that we're used to fill the rest of the world.
Right.
Mostly it's WGS84, let's say.
Okay. All right. And then the next question came from a gentleman who says, is the green area equivalent to 60 BDU contour, or can 60 be specified? Now, we didn't show it. We could go back, but there are actually some pull downs that allow you to specify different coverage levels. We have the receiver showing 34 and 44. We have 2 European levels, and we can certainly add more. Is that right?
Yes, as needed.
Okay, so one of the possibilities is this gentleman is requesting that we have one that maybe shows 60 and 70. Is there any possibility, Roger, at any point, the model does not include population statistics. We have one customer who's interested in the possibility of determining the number of people that live within a particular geographic area.
That will mean to have access to a database that we don't have now.
Okay.
That will link the area of interest to population.
Okay.
Well, since we do have a picture, the coverage picture, which is a color over a white area, and it's geo-referenced as well, I think that somebody that is clever with you know, geo-referencing software, geo software will be able to use that.
But you'd have to own that database, that's right.
Yeah, you need to have some skills in geo mapping.
Okay.
And use external software.
I think the next question we've answered, it asks, can you enter latitude and longitude according to the FCC standard, which uses NAD 27?
Latitude longitude does not make sense. It will be a UTM issue if you use UTM entry. So since we use lat long, it's not really a problem here.
Okay. Okay. There's a gentleman that's asking about the possibility of using directional antennas. One of the things that I should mention is that your software package, Radio Mobile, is capable of doing all of what this does, but so much more. There are so many additional features that your software has, but that comes at the expense of being a bit more complex, especially for a non-technical user. So within the Radio Mobile software, which is also free, by the way, that software allows you to import directional antennas and see the coverage based on a directional antenna. Is that correct?
Yeah, but I would say that if there is a need for more antenna type with different gain, it's up to Nautel to please their customer. I mean, if there is a need, we can change that. We can add more in the list, in the actual list.
Okay. And this is one of the reasons for doing this webinar today, is to solicit ideas and content that we may want to do in the future. Again, the goal was to provide something that's dead simple. It doesn't have a lot of optimization and customization so that, that just somebody who wants to just try some things out wouldn't get put off by having too much information they don't understand. A friend of mine from New Zealand has asked the same question we just got before about the population covered, and unfortunately at this point in time, since we don't have the database, that's not possible. Another gentleman is asking if it's possible to lower the default power choices below 300 watts, and yes, we could do that. We could have some other estimated power levels and antenna gains to do that. So that's the answer to that question from the Philippines, I believe. So that's what I've got so far. Is there anything that, Roger, you'd like to add? I think we've pretty much hit our time schedule.
Okay, no, it's okay. I would just like to thank everybody for using the tool and give us some feedback. That will the best thing to progress.
That's great. And I once again, I'd like to thank you, Roger, for all of your hard work on this, and which benefits the broadcast community and the radio amateur community as well. Thank you very much. If there are questions, you can email me either at sales@Nautel, or my email address is ckelly@nautel.com. For Roger Coudet, I'm Chuck Kelly for Nautel. Thank you very much, and bye.